So today's lesson is on significant figures. Now this is going to be the main avenue for which you're going to get this information. I'm not going to spend a lot of time going over this topic in class. I'll have a quick review, but that's about it. So this is the main lesson for this particular concept. Now you're going to have to understand that we are going to have some assessments on this, or another quiz or test, but we're not going to make it a major part of the year. So you do have to understand what significant figures are, why are they important, and then how to determine them. But we're not going to be harping on this for the rest of the year, right? So the lesson is, what are they, how are they important, or why are they important? How do we determine what the significant figures are in a measurement? Okay, significant figures, we also call them SigFigs. Significant figures are important as they indicate how exact a number or measurement is. They describe the exactness or with what resolution the measurement was made. And this is important when you're looking for very fine details or very small differences in measurements. The more exact you can make the measurement, the more you can say whether or not there's a difference in the measurement from another measurement. A measurement includes all the digits that are accurately known plus a last digit that is estimated. And that's very important, because if you only have one significant figure in your measurement, that measurement is basically somewhat estimated. You need to have at least two significant figures in your measurement to have one to be exactly known and one to be somewhat estimated. Only measurements have significant figures. Conversion factors, multipliers, non-measurement numbers, phone numbers, license plates, street addresses, whatever, do not have any significant numbers or figures, right? And the last thing that is very important to understand is that SigFigs do not have any relevance on accuracy or precision. Just because something is measured very exactly doesn't mean it was measured very accurately, or doesn't mean that it's measured very precisely with respect to other measurements in the data set. That's very important to understand. Exactness and accuracy are totally different in the eyes of the scientist and engineer. Okay, so let's talk about exactness and what it is in a measurement. Look at these two rulers. Now the red line is the same length for both of the rulers. Which ruler would you use to measure that red line, and why? Both rulers are in centimeters, by the way. Well, I would think you would say that I'm going to use the green one. Why? Because the green one has a lot more smaller increments. Remember, an increment is the smallest thing that we have a tick mark for, or a scale for. And therefore, this 1 centimeter is actually broken down into 0.1 centimeters. Whereas this ruler here has the increment in 0.5 centimeters. So I have a lot more resolution with this one than I do this one. Therefore, my estimate for my number is going to be a lot better using this ruler and this than this one, right? So therefore, I should get a more exact measurement from using this scale than I should using this, because my estimate here is going to be plus or minus 0.1, because my 0.5 is the smallest increment, where here is my estimate's going to be 0.01, because my smallest increment is 0.1, right? We're going to always estimate one more position past the smallest increment. So that's what we mean by exactness. Now, how does that relate to significant figures? Well, you will find when you do your measurement here and make your measurement, you're going to have more significant figures in this measurement than you would in this one. All right? So let's just take a quick number here. Let's say I'm going to look at this and say that this is 2.5. It's more than 0.5, but less than 3. So I'm going to say it's somewhere around looks like 2.7. But my 7 is estimated. It could be 2.6, or it could be 2.8, it could be 2.75, but it's 2.7. However, on this one, I know for a fact that it's more than 2.5. It's more than 2.6. It looks like it's just at 2.7, but I'm not quite sure if it's 2.68, 2.69, or 2.71. but I do know it's more than 2.6, and therefore I have a little bit more exactness in this measurement than I do in this one. We use a very simple rule called the Atlantic-Pacific rule to determine the number of significant figures. And it basically boils down to this. Envision a map of the United States. On the left-hand side is the Pacific Ocean. On the right-hand side is the Atlantic Ocean. And in between is the continental United States. Now, let's say you would put your measurement number right here in between the two oceans. The question that's asked is, does your measurement have a decimal present, or does your measurement have a decimal that is absent? If the decimal is absent, absent starts with A and so does the Atlantic Ocean, we're going to do our significant figure count from this side, from the right to the left. If the decimal is present, present starts with a P, so we're going to count from the Pacific Ocean side, so we're going to go from right to left into this way. And again, it's the same rule. We start our count at the first non-zero. Every digit after that is counted and is significant. So let's see how this works in the others on the next page. Let's apply the Atlantic-Pacific rule to a series of numbers here to show you how we can calculate the number of significant figures and what they are. So I've already written P and A to indicate the Pacific side and the Atlantic side. And remember, our numbers here are in the middle where the continental United States would be. So the question we ask for every number is the decimal present or is the decimal absent? And our first one is the decimal is absent. So when the decimal is absent, we go from the Atlantic side. Atlantic, absent. So we're going to start our count from this side and go that way. We start our count at the first non-zero. That doesn't count, that doesn't count, that counts. Everything else, there's nothing after that. So we only have one significant figure. The next example is 500.0. Now in this example, is the decimal present or is the decimal absent? And you would say the decimal is present. So we're going to count from what side? Present means Pacific, so we're going to count from this side. It's the same thing as we did before. We start at the first non-zero and every digit after that is counted. So here we have our first non-zero, 5. Every digit after that is counted, 2, 3, 4. So there's 4 significant figures here. Now you may ask the question, why is there 4 significant figures in this measurement and there's only one significant figure in this measurement? Well, now recall what I said to you, that when you only have one significant figure, that figure or that number is estimated, right? And we only have one here. So there is some uncertainty in whether or not this is truly 500. It could be 490, it could be 480, it could be 520, it could be 510, because this is somewhat estimated, right? This could have been rounded up or down to get 5. In this case here, we know it's more exact to 500. Why do we know that? Because somebody has taken the time and effort to measure not only the hundredths place, but also the place of the tens, the ones, and the tenths. So 10, 1, and tenths have all been measured. So therefore there are 4. And the only thing that we're uncertain of is this last one. It could be 500.1 or maybe it's 499.9. But it's a lot more exact to 500 than this one. And that's why it has more significant figures. So let's look at the next couple real quick. We're going to go through these real quick. Does this have a decimal? Yes, it does. So we're going to say it goes from this side. And we're going to start our count again. We count at the first non-zero. The only non-zero in this one is 5. So we only have one significant figure. Now you could come back and say, well, wait a minute. In this case here, we have 3 zeros, a decimal, and a 5. In this case here, we have 3 zeros, a decimal, and a 5. Why does this only have one significant figure and this one have 4? Well, and the answer is that when you have numbers in front of your only significant figure, so in this case 0.005, these are just holding place. These just tell you that you're in the 1,000th place here. They have nothing to do with how exact the number is. That's the difference. These actually have significance because they have been measured all the way out to the 10th place. These have not been measured, right? This could be just be on a scale here, and this is the only thing that you actually have a number for. So this is the only reason you have a significant figure. You'll see on the next one, let's do the next one real quick. It has the decimal, so it's going to be from this side, and we're going to do the count, and you'll see that the count is nothing till you get to here, and then the rule is everything following it is significant, so 2 and 3. So this has 3. And why is this one now less exact than this one? Again, they're the same number, right? 0.005, 0.005, but this one has a couple of zeros tacked on to the end. What it says to you here is that the instrument used, or the person making the measurement, has taken the time to measure not only the 5 exactly, but has gone out to the 10,000th spot and then the 100,000th spot where the estimate is made. So it has a lot more exactness than this one. So therefore it has more significant figures. And the last two are real quick. Does this have a decimal? It does not. So we're going to count from the Atlantic side, and if you do the right count, you're going to see that you get 3. And then on this side, we're going to say it does have a decimal. The decimal is present, so it's got also 3. Again, we don't count the 0 before the decimal. Right, so hopefully that gives you a better understanding of how to count them and why there's a difference between some of the ones that look like they should have the same, like this one and this one, but they're really different. If you followed any of my videos, you know that there's a small section at the end of the video making sure that you understand it and do it on your own. So I've given you a list of measurements here on the left-hand side. I'm asking you to calculate the total number of significant figures, and I'm asking you one more extension of that is to tell me which of those are significant. So for example, and I'm not saying this is right or not, if we look at this number here, you might say that there's only 2 significant figures, and the significant figures are the two ones. So this is significant, this is, everything else isn't. Right? I'm not saying that's the answer, but that would be it. All right, and then this one you could say all the numbers are significant, whatever. Right? So you're going to list how many, and then what are they. All right, so now when you are ready, you're going to stop the video, write all this information down, complete the problems, and then restart the video when you are ready. So stop the video now. Okay, so here are the answers. Hopefully you've got them all right. If not, see if you can go back and figure out where you went wrong. Consult your book, or better yet, come find me and I can quickly get you up to speed on this. Right? Remember, this is not something that we're going to go over a lot in class. So if you still struggled with it, you should really come find me so I can get you on the same page. We're not going to harp too much about this on for the rest of the year, but you will have some assessment on it earlier in the year. And you just need to be aware of what these things are as you move forward in life.